Hello, and welcome to video 4 of Module 4, Interpreting the Slope and Y-intercept of the least squares regression line. In this video, we'll be looking at an equation of a least squares regression line and discussing how to identify the slope of the line, as well as how to identify the y-intercept, and what those values mean, and whether or not it makes sense to interpret those values given the context of a problem. Let's get started. Just a reminder that throughout the videos of Module 4, we've been exploring some data that Harriet collected about the displacement volume and the combined city and highway mileage for our several vehicles from 2017. Harriet has also determined the least squares regression line to be y hat equals 34.103 minus 2.804x. Just a reminder that the x value is representing the displacement volume, which is measured in liters, and the y value represents the combined city and highway gas mileage, which is being measured in miles per gallon. Let's use this information to discuss the slope and y-intercept of Harriet's line. Let's start by interpreting the slope of Harriet's least squares regression line. To help us out, I've put the equation up here at the top of the screen. So what is slope? Well, slope is an average rate of change, and it's always going to have units that are y units per x units. Here's the difference between an average rate of change and an instantaneous rate of change. An average rate of change is like, let's say I'm driving on a highway, and for the most part, I'm keeping a pretty good highway speed, but sometimes I might have to slow down or speed up depending on, what's going on around me. But generally, maybe I'm traveling at about 70 miles per hour. So that 70 miles per hour that I'm generally traveling at is going to be my average rate of change. The speed that I'm going in an instant would be my instantaneous rate of change. So at any particular moment in my driving along a highway, that's going, whatever my speedometer reads, right, at that particular moment in time, that is my instantaneous rate of change. So our slope is going to be an average rate of change. So we're going to find the slope of Harriet's least squares regression line. To do that, you want to find the value in the equation that's the coefficient of x. In other words, what's the number just before the x in the equation? In this case, it's that negative 2.804. Notice that we were subtracting the 2.804x from the 34.103. So that subtraction is important because it's going to mean our slope is a negative number. So that subtraction sign plays double duty as subtraction and as a negative when we report our slope. If we had been adding 2.804x, then the slope would have been a positive number. The next thing we need in order to determine the slope are our units for x and for y. X represented the displacement volume of an engine, so x is going to be measured in liters. So our units for x are liters. Y represented our miles per gallon, so the y units were mpg. So putting all of these components together, the slope of Harriet's least squares regression line is negative 2.804 miles per gallon per liter. Okay, but what does this mean? This means that for every additional liter of volume that is different between two vehicles, their gas mileage will be different by the slope. Here, since the slope is negative 2.804 miles per gallon per liter, that means for every additional liter of volume that's different, their gas mileage will be different by 2.804. Now, in this case, I'm not mentioning the negative part because I'm just indicating an amount by which the mileage is going to be different. So you could put the negative here or not. I'm choosing not to put it here since that's an amount that they're different by. So let's look at an example of putting that into context. So the Ford Focus and BMW 440i Coupe have displacement volumes that differ by 2 liters. So we've been asked, by what amount would you expect the gas mileage to be different? So what the slope means is that for every difference in x, you're going to expect a difference in y of the slope. So since I have a difference of 2 liters, there's 2 liters of difference, I need to multiply that by the slope to figure out the difference in mileage. So because my two vehicles differ by 2 liters, I multiply that by 2.804 miles per gallon per liter, and I get 5.608 miles per gallon. All right, so now that we've discussed the slope a little bit, let's talk about the y-intercept. So the y-intercept is the value that you get when x is 0. And it will always have the same units as the y variable because it's the y-intercept. To identify the y-intercept from the equation of the line, you want to look for the value which is not attached to the x. So for part F, to state the y-intercept of Harriot's least squares regression line, we're going to look at the equation and find the value that doesn't have the x beside it. In this case, that's the 34.103. Because the y value represents gas mileage in miles per gallon, the y-intercept will also have units that are miles per gallon. So the y-intercept of this equation is 34.103 miles per gallon. Okay, so let's see if that actually makes sense to have. So the y-intercept is appropriate to interpret, meaning it's going to make sense in context if you have both positive and negative values for x. So the question here is it appropriate to interpret the y-intercept of Harriot's least squares regression line? And explain. So in this case, we have to think about what an x value represents. An x value represents the displacement volume in the engine. So you can't have 0 displacement volume. That would mean that the engine doesn't move, or there's no engine there. And so you wouldn't have a car, so gas mileage wouldn't make sense. So to have an x value of 0 does not make sense in the context of Harriot's data. And 0 doesn't make sense. Negative numbers wouldn't make sense here either. So no, an engine can't have a negative or 0 displacement volume. For an example where the y-intercept might make sense would be, let's say the x value represents winter temperatures and the y value represents, I don't know, days off from school. So maybe you have more snow days when it's cold. I don't know. But in that case, an x value of 0 or a negative x value may make sense because you could have both positive and negative temperatures in the winter. So in that case, the y-intercept would have made sense because those sorts of values would be expected for the value of x. It might also make sense, for instance, if x is representing sea level, right? So you could be a certain number of feet above sea level or a certain number of feet below sea level. And that might change, I don't know, atmospheric pressure, say. So in that instance as well, the y-intercept would be appropriate to interpret because the x values could take on positive or negative or 0 values. All right, that concludes our video on interpreting the slope and y-intercept. In the next video, we'll take Harriot's least squares regression line and we'll talk about how you can graph it over your scatter plot. Thanks for watching and have a wonderful day.